B. Roll a die twice. What is the probability of getting at least 1/6? Probability of getting at least 1/6. In this statement, getting at least 1/6, you roll a die twice. First time you roll a die, you get a number, maybe 1. The second time you roll a die again, you get the second number. So when you roll a die twice, you got a combination of two numbers. Okay. One may be 6, one may be 2, 6 and 2. So one of them is 6. But also you may also get 6 in the first time and 6 in the second time. Okay? So the combination of two numbers could be 6, 2, 6, 1, 1, 3, 6, 6, so on and so forth. Now the question asks, what is the probability of getting at least 1/6? That is, within the combinations of two numbers, at least one of them is a 6. Now this statement does not exclude the scenario where you have a combination of two numbers of both of those numbers are 6. So this statement, getting at least 1/6, is a composite statement that contains actually two possibilities. That is, you have 1/6 only, and also you have 2/6. Okay, so let's first show the process using some visual device. Then we can see more clearly, okay, how this composite statement actually works. What does it actually mean? Okay. Now you roll the die twice. Let's roll the die first time. When you roll a die, you may get 1, or 2, or 3, or 4, or 5, and or 6. So that's the 4. That is the 6 possible outcomes. Now, if the first round you get 1, and the second time you roll a die again, what are the possible outcomes? Second round? Well, if the first time you got 1, second time you roll the die again, you can still get 1, 2, 3, 4, 5, or 6, right? Now, if the first time you got a 2, and the second time you roll a die again, you could possibly get 1, 2, 3, 4, 5, or 6. And similarly, if the first time you got 3, the second time you can still get 1, 2, 3, 4, 5, or 6. And the same principle applies to all scenarios, all numbers. Okay, now let's summarize what we can get here. What are the total possible outcomes in rolling the die twice? Now, if the first time you got 1, second time you got 1, so you would end up having a combination of two numbers, 1 and 1. If the first time you got 1, second time you got 2, you have this combination of 1 and 2. If the first time you got 1, and second time you got 3, you would have the combination of 1 and 3. And if first time you got 1, and second time you got 4, you would have the combination of 1 and 4. and so on and so forth. So you can really see the pattern is very clear. So you have just 6 possible outcomes of combinations of two numbers: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, or 1, 6. Now, if the first time you got 2 and the second time you got 1, you would get a combination of 2 and 1. And if the first time you got 2, second time you got 2, you would get a combination of 2 and 2. Okay? And similarly, you could also get a combination of 2 and 3, and 2 and 4, and 2 and 5, or 2 and 6. That's very clear. And apply the same principle to all other possible cases. So you could get 3, 1, 3, 2, 3, 3, so on and so forth, or 4, 1, 4, 2 through 4, 6, or 5, 1 through 5, 6, or 6, 1 through 6, 6. So you have this 36 possible outcomes, 36 possible combinations of two numbers. So these 36 numbers, 36 combinations of two numbers are the total possible outcomes when you roll a die twice. Now, what are the outcomes that we are actually interested in? Here, we go back to this probability statement, getting at least 1, 6. This contains the scenario where the combinations of two numbers contain 1, 6 only. 1, 6 only. Okay. Now, let's first look at the what are the outcomes that contain 1, 6 only? Here, 1, 6 is a combination that contains 1, 6 only. 2, 6, in the same way, 3 and 6, 4 and 6, 5 and 6. Look at the last column, 6 and 1, 6 and 2, and 6 and 3, 6 and 4, and 6 and 5. All these combinations contains only 1, 6. Therefore, we have 10 possible ways to obtain combinations of two numbers that contain 1, 6 only. Therefore, we can first calculate the probability of getting 1, 6 only. Okay, we have 10 ways to obtain combinations of two numbers that contain 1, 6 only. What is the total number of possible combinations of two numbers? We just said that 36. So it's 10 over 36. Okay. As we said early on, getting at least 1, 6 also includes the scenario where we have 2, 6. Okay. Now, how many ways we can obtain combinations of two numbers that both are 6? So only one way here. So the probability of getting 2, 6 is simply 1 over 36. Therefore, when we eventually come to calculate this composite probability of getting at least 1, 6, we just combine the probability of getting 1, 6 only with the probability of getting 2 6s. So that is the probability of getting at least 1, 6 is 10 over 36 plus 1 over 36. And that gives us this final results. So when I said early on, show your work, what I mean here is that you need to show all these 2 rounds of rolling a dice and summary, and also those individual probability calculations. Also, eventually you come up with this composite probability. This is what I mean by show your work. Okay, do not just give me 11 over 36. You need to show this work. This is what I expect from your assignment. Okay. Sampling with replacement. Now we know from the class reading material, this means that you take a sample, you take a case, and before you draw the next sample, you place whatever you draw in the first time back into the pool. Now you draw it again, so that within the pool, the total number of cases that do not change, and the composition of the cases that do not change. So that makes the different round of drawing the probability of getting a certain result from different rounds of drawing do not change. And we call this independent. Now in this question, we sample with replacement. Draw a ball twice from a bag of 3 balls. So within the bag you have red, white, and blue balls. After 2 rounds of drawing, you end up having 2 color balls, right? And here question is, what is the probability of getting a red ball and a white ball? Again, we are going to use some visual device to show this process, and to determine the probability of getting a red ball and a white ball when you draw a ball twice from this bag. Now, first round, when you draw the first ball, within the bag you have 3 balls: red, white, and blue. So the first time when you draw a ball, you could get red, you could get white, or you could also get blue. Okay, that's 3 possibilities, 3 possible outcomes. Now, the second draw. Now, since we are sampling with replacement, that means that whatever ball you get the first time, you need to place that ball back into the bag before you draw the second time. So when you put the hand into the bag again, there's still 3 balls there. There's still 3 balls there: red, white, and blue. Now imagine the first time you get a red ball. What are the possible outcomes for the second draw? It is still red, white, or blue, because the 3 balls are still there. You could get any of them. Well, if the first time you get a white ball, the second draw you can still get red, white, or blue. If the first draw you get a blue ball, the second draw you could still get red, white, or blue. Now let's summarize. After drawing 2 balls, what are the possible outcomes of combinations of 2 balls? If the first time you get a red, the second time you get a red, then you could get red and red. If the first time you get a red, the second time you get a white, now you can get red and white. The first time you get a red, the second time you get a blue, now you could get red and blue. If the first time you got white, the first and second time you got the red, you could get white and red, or white and white, or white and blue. If the first time you got the blue, and the second time you got the red, you could get blue and red, or blue and white, or blue and blue. So you have how many possible outcomes of 2 balls? 1, 2, 3. You have 9. You have 9 total possible outcomes of 2 balls after 2 rounds of drawing. Now, what are the outcomes that we are actually interested in? We are interested in a combination of red ball and a white ball. Doesn't matter what is the order that we get the red ball or white ball, as long as we have 2 balls, one of them is red, the other is white. Now, how many ways we can get a combination of red and white? 1 and 2 and 2. Therefore, the probability of getting a red ball and a white ball is 2 over 9. 2 over 9. Okay. D, sampling without replacement. We know from the class reading material, this means that after we draw an item from a pool, then if we want to draw another item from the pool, we do not place the items we draw the first time back into the pool. So now the total of items in the pool and the composition of the items within the pool changed. Therefore, the probability of getting a particular item will also change. So the probability between different rounds of drawing items from the pool is not the same. So they are not independent of each other. Okay. Now, sampling without replacement. Select randomly a student from 10 students. Within these 10 students, there are 4 males and 6 females. What is the probability of getting a female student? After selecting a female student, what is the probability of getting another female student? Okay, let's see. First selection. When you select a student first time, in the pool of 10 students, there are 4 males and 6 females. Therefore, the total number of possible outcomes is 10. And you have 6 different ways to obtain a female student. Therefore, the probability of getting a female student in the first selection is 6 over 10. And you simplify that to 3 over 5. This is the first selection. Okay. Now, after we obtain a female student, we're going to go back to the pool to select another student. The question is, now, what is the probability of getting a female student? Now remember, this question we said is sampling without replacement. After we obtain the first female student from the pool, we go back to choose another student. Now we do not place the first female student back into the pool. We do not, this is sample without replacement. So if the female student was selected and she is no longer in the pool anymore, and now within the pool, how many people remain. There's only 9 students left. Now, if the first student selected is a female, and this female is no longer in the pool anymore, so within this 9 students, how many ways will obtain female students now? There's only 5 ways to obtain a female student. Therefore, in the second selection, the probability of getting a female student is 5/9.